Now let's go ahead and look at some examples of sample spaces and events by looking at some experiments here. Suppose we toss a pair of coins and observe their outcome. Now the best representation of the sample space would be, the set would be head head, head tail, tail head, or tail tail. Now if the event we were interested in, let's say E1, was the event of getting no heads, then the only way to get no heads would be to toss tail tail, and that's a simple event. The event of getting exactly one head would be head tail or tail head. That's a compound event. The event of getting at least one head, then we would have to throw in the event of head head here, so that we would get 3 elements here, and that would be a compound event. The event of getting less than 3 heads, well, all of them fit that category because all 4 of these have less than 3 heads, so that's a compound event. And the event of getting exactly 3 heads, well, that's impossible since we're just tossing 2 coins, so that would be the empty set. Another experiment. Suppose we select a 3-card hand from a standard deck. The best representation of the sample space would be S is the set of all possible 3-card hands. Consider the following events. Let's say event 1 is the event of getting the Jack, Queen, and King of Hearts. Well, there's only one way you can get that, and that's to just choose that hand, Jack, Queen, and King of Hearts. So that's a simple event. What about the event of 3 kings? Well, there's 4 ways to get 3 kings. You can get hearts, spades, or diamonds, hearts, spades, or clubs, hearts, clubs, or diamonds spades, and clubs. So there's 4 ways that can happen, so that would be a compound event. And what if I said the event of at least 1 ace? Well, there's lots of ways to get 1 ace. It would be all the hands that have 1 ace, all the hands that have 2 aces, all the hands that have 3 aces. So that would be a compound event. And what about the event of getting 3 red kings? Well, again, that would be the empty set because there's no way that you can get 3 red kings. And in the third example, suppose we roll a pair of fair 6-sided dice and observe their sum. The best representation of the sample space would be all of the 36 possible rolls. Now, normally I don't write all these out, but I wrote them all out for you here so you can see them. The event of a sum of 2 would be a simple event because there's only one way here to get a sum of 2. The event of a sum of 5 or of a sum between 4 and 7, both of those would be compound events because there's multiple ways that could happen. And then the event of a sum of 1 would be the empty set because there's no way you can get a sum of 1 if you toss 2 die. And then the event of a sum greater than 1 would be the entire sample space because all of these give you a sum greater than 1. Now let's look at an empirical example. Suppose 3 candidates run for office. We'll call them Smith, Jones, and Brown. The probability that each wins are, the probability that Smith is going to win is 0.58, the probability that Jones wins is 0.12, and the probability that Brown wins is 0.30. Let's let E be the event of Mr. Long winning. Well, Mr. Long's not running, so that would be the empty set, and so the probability of that event would be 0. Let's let E be the event Mr. Jones wins. Well, that event's already assigned to be 0.12, so we know that probability is 0.12. And then let E be the event Mr. Smith or Mr. Jones wins. Well, the event that Smith or Jones wins, we would simply add these two together to get the probability. And we'll talk more about that later. Now, the next thing I want to talk about is how do you, a little bit about the probabilities for your simple events. So let's say you have a sample space and you've got a bunch of simple events in there. We'll just say that you have n of them. E1, E2 through En, and to each simple event we'll assign a real number and we'll call that number P sub EI, and that means the probability of the ith simple event. So these numbers can be assigned in any arbitrary manner as long as only 2 conditions are satisfied. Now we're not saying that they're always going to be the same, but it depends on the experiment. But the 2 things that have to be satisfied when you assign probabilities to a set of simple events are, 1, the probability of each simple event must be a number from 0 to 1. 0 to 1 inclusive means that it can be 0 or 1 or anything in between. So the probability of each simple event must be from 0 to 1. And then finally, the sum of the probabilities of all simple events in the sample space must add up to 1. So in other words, the probability of each simple event when you add it up must equal 1. And as long as the probability assignment meets these two conditions, it's said to be an acceptable probability assignment. Let me show you some examples of some probability assignments. Let's go back to the example where we toss a pair of coins. Okay, so we have the sample space here of these 4 possible outcomes: head, 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 tail, tail, head, or tail, tail. So some acceptable probability assignments would be this one here would work, because here we're just letting the probability of each one be 1/4, and they satisfy the two conditions. They add up to 1, and they all fall within the range that we need. You could also assign them this way. I'm not saying that this is how they should be assigned, but it could be. This would still work mathematically. The probability here of each experiment is between 0 and 1 inclusive, and they add up to 1. So if you add up these 4 numbers, they add up to 1. Or you could also assign them this way, where the probability of the first 3 simple events are 0 and the last one is 1. It still meets the criteria where the probabilities all range from 0 to 1, and then if you add them all up, they add up to 1. Now down here, these would be unacceptable. Notice this first one here, if you added up 0.4, 0.4, 0.3, and 0.3, it would not add up to 1. And then down here, these actually do add up to 1, but you'll notice that 1.2 and negative 0.4, those two numbers are values that are not allowed when we assign probabilities. So these two sets would be unacceptable. So now let's look at something else. Suppose 3 candidates run for office. Let's go back to our 3 candidates here. The probability that each candidate wins are 0.58, 0.12, and 0.30. This is acceptable. But if I assign the probabilities this way, 0.8, 0.12, and 0.30, then that wouldn't make any sense. So that would be an unacceptable probability, because if you add these up, the probabilities don't add up to 1. Okay, so that, in the next video, I'll talk about the probability of an event E and how we can calculate it.